In this video, we're learning what the inverse of a function is and how to find it, both algebraically and graphically. So when we're finding the inverse of a function, what we're trying to do is undo all of the things that happen to x, meaning we want it to say x equals instead of y equals. So to do that, we're just going to solve for x. Now, most of the time when you're solving for x, there's no other variables, but we're going to keep y with our variable. So to solve for x, we would first subtract 5 from each side. We'd get y minus 5 is equal to 2x. And we'd divide everything by 2. So we'd have y minus 5 all over 2 is equal to x. This portion over here, y minus 5 over 2, this is the inverse function. Now, most of the time when you have a function, it's written as f of x. To write the inverse function, you write f inverse of x. So it's f raised to the negative 1 power. And we're using x, so I will put an x in for y. You have x minus y, or x minus 5 over 2. Here's my inverse function. Now I've got domain and range for the function and the inverse function. Notice for 2x plus 5, it's a graph that crosses at 5, has a slope of 2, so it looks like this. The domain of this function is all real. The range of this function is all real. For the inverse, I have x minus 5 all over 2, which could be written as 1/2 x minus 5/2. So this thing would be crossing down here, and it would have a slope of 1/2. So it would look like this. Notice that my domain is all real, and my range is all real. So in both cases, the domain and the range are all real. Now, if I draw in a dotted line through here, it's really hard to see with my graph, but this line is the y equals x line. And all I'm doing is reflecting this graph across, which we'll discuss more in the next problem. When I reflect this across, because my y is now my x and my x is now my y, remember that for domain, we have the x values, and range, we have the y values. For the inverse problem, our y is now x and our x is now y. Or in other words, the value for our domain is now the value for our range, and the value for our range is now the value for our domain, because all we did was switch x and y. Which means if you can find the domain for your function and the domain for your inverse function, that will tell you the range for the other ones. Now, as we look at this graph, as I was saying before, with our y equals x line, so we have a line that would go up through here. There's our y equals x line. Now with this line, this represents our line that reflects across y equals x, meaning that all of our x values become y values and our y values become x values. So this point that's right here at 4, negative 4, would then become negative 4, 4. And notice that all I did is reflect it straight across this y equals x line. I could do the same thing if I pick this point right here. That's negative 2, negative 6. It would then become negative 6, negative 2. This point is 0, 0, so there's no reflection point here, which means this line is then reflected over this way. This line is reflected over this way. And then I would need this point. So this point here, which is 8, 4, it is now 4, 8. And we have this line here. And as you can see, it is a mirror image. This one on the left is a mirror image of this one on the right, just reflected across this y equals x line. Now again, all that we did was we took the x minus y, or x comma y from this side, and we switched the order to become y minus x, or y comma x for the inverse. We just switched the numbers and then graphed them as if they were x comma y. That's how you'll find the inverse of a graph and also the inverse of a function.